Hello everybody, today I'm going to show you how to make a maze generation algorithm in Unity. First I'm going to explain the algorithm itself. This is called a depth first search. It works by choosing a random starting node and picks random nodes available next to it. When there are no available nodes next to it, it backtracks until there is. It repeats this process until all nodes are picked. So how is this implemented? So we have two lists, a current path and a completed nodes list. The current path is represented by yellow, the completed nodes list is represented by blue, and the available nodes, meaning that a node isn't in either list, is represented by white. We pick a random starting node and add it to the current path. We'll call the last node in the current path the current node. Every step, we check the nodes next to the current node and see if there are no white nodes. We pick a random white node next to it and add that to the current path. We keep doing this until there are no white nodes close to the current node. Then we backtrack. We move the current node to the completed nodes list and removing it from the current path. Then we check the new current node to see if there are any available nodes next to it. We keep doing this until there is an available node next to the current node. Then we just repeat the process again until there are no more white nodes. Okay, so in a new Unity project, we're going to first create the maze node itself. So just create an empty game object, and we're just going to call it maze node. I'm just going to reset the transform. Then inside of this, we're going to create a new cube, and we're just going to set this to, on the y-axis, -0.5. The scale for the y-axis is going to be 0.1, and on the x and z-axis, we're just going to do 1.1. And we're just going to call this wall on floor. And then we're going to make pause x wall. So this is going to be the first wall. And we're going to do, whoops, that's not right, 0. And then for this one, it's going to be 0.5 on the x-axis for the position. And for the scale on the x-axis, we're going to do 0.1. Y-axis 1 and z-axis 1.1. And we could copy that and make this negative x wall, and it's the same thing but with a negative 0.5 for the x position. And then we're going to copy it again and do pause z wall, so we can just set this back to 0 for on the x-axis, and then we're going to do 0.5 on the z-axis. And for the scale, we're going to do 1, 1, 0.1, or sorry, 1.1 on the x-axis. And for the negative z, we're just doing the same thing, but with negative 0.5. Of course, you can make the maze node however you want. This is just the way that I'm doing it for the tutorial. Okay, so now inside of the maze node object, we're going to create a new script called maze node. And open that up in Visual Studio. Okay, so inside of Visual Studio, we could just get rid of all this stuff. And we're going to create two variables. One is going to be a list of array of game objects called walls. And we're going to have another one, which is going to be a mesh renderer. Just simply called mesh renderer, doesn't really matter. Or we can actually just call this floor. There we go. That's just the floor. You don't need that if you're not going to have a floor, but we're using the floor to signify, to like show the state of each of the nodes. So next up, we're going to create a method called setState, and it has to be public. And it's going to be integer, or it's going to take in an integer called state. And actually, instead of an integer, we're going to make an enum because that's going to be a lot easier. So we're going to say enum node state, or sorry, public enum node state up at the top above this class. And in here, we're going to do 3. We're going to do available. Oops, wait. Forgot how to spell. Available, current, and completed. Okay, so now we can take in this node state instead, and this will just make it easier to see what's happening inside of the other script. All right, so we're gonna need a switch statement that's gonna take in state. Whoa, what the heck is this? There we go. Visual Studio 2022 is a little weird sometimes. And then inside of this, we're gonna do case available. We're just gonna set the floor material color to color.white, and then put the break. And then next up, we're gonna do current. We're gonna do floor.material.color is equal to color.yellow. You can set these colors to whatever they want, it doesn't really matter, but this is just to signify what they all mean. And then last we need, if the state is completed, then we're just gonna set the floor material color to blue and break. That's all you need for right now. And this is, again, you really only need this if you want to show the color of the state. Okay, back in Unity, we can add the script, if you didn't already, to the maze node object. We can just put floor in here, and you have to make sure that the walls are in the positive x, negative x, positive y, and negative y. It has to be in that order, otherwise you'll get weird results. Alright. And then you can just drag this into your prefabs folder, or just down here to create a prefab. And you can delete it from the scene. Okay, next up we're going to create a new empty game object, and we'll call this maze generator. I'll just reset the transform, and then create a new script on this called maze generator. And you can open that up in Visual Studio. The first thing we're going to do, once again, just delete everything. Then we're going to create two variables. One of these variables is going to be a maze node, and that's just going to be called node prefab. That's just to instantiate them. And we're going to create another variable. It's just going to be a vector2 int called maze size. Now we're going to create a start method, and inside of this, we're going to, for right now, we'll use a coroutine just so we can see it better and have like a nice visual. And then we'll switch it to just a regular method so it's instantaneous later. So we're just going to start coroutine and generate maze. Alright, so now we're going to create this. So it has to be a type IEnumerator called generate maze. And we can take in the maze size as well. And we can put that in here. Okay. So inside of this coroutine, we are first going to get, or to create a list of nodes. This is just going to be for all the nodes that it creates. And we'll just call this nodes. So it's just to a new list. And then we're going to create two for loops. Actually, I'm going to comment this saying create nodes. So now we're going to have two for loops. One of them is going to be for the x-axis. Why did it do that? I don't know. Okay. And it's just int x equals 0, x less than size.x, x plus plus. Pretty simple. And we just have to do the same thing for the y-axis. And then inside of here, we're just going to need to create each of the nodes. So the first thing we need is a vector3 called node position. I'm just going to set this to a new vector3 that is x minus, in parentheses, size.x divided by 2f. And then on the y-axis, it's 0. And the z-axis is just y minus, parentheses, size.y divided by 2f. And what this does is this centers it around 0, 0 instead of having the bottom left corner as 0, 0. Next up, we're actually going to instantiate the new node. So we're going to say maze node new node is equal to instantiate node prefab, node pause for the position, and then for the rotation, we're just going to do quaternion.identity. And we're going to set this as the parent. And then we could just simply add this new node to the nodes list. Okay, so now if we just add in a yield return null so that it actually, so that it stops giving us an error, then we can come back here drag in the prefab over here, and then set the maze size to, we'll just do 10 by 10 for right now. And the main camera, you're also going to need to adjust that. So I'm just going to set the z-axis to 0, y-axis to like 15, and the rotation on the x-axis to 90. That's facing downwards. I think that should be good. Yeah, there we go. There we go. We now have all of the maze nodes being generated. So now the next step is to choose the starting node. So to do this, we're first gonna need to actually create our list that we talked about earlier. So we're gonna need a list of maze nodes called current path. And we're just gonna set this to a new list. And another list of maze node called completed nodes. And once again, just set it to a new list. And then we're gonna get current path dot add, and this is just to actually pick the starting node, and we're just gonna set it to a random node. So nodes random dot range 0 to nodes dot count, and there we go. And then we'll comment this off saying choose starting node. And then we're gonna then we're just gonna set this current path, or set the state of the current path to node state.current, because now it's inside of the current path list. Okay, so now this should choose the starting node. And there we go. So next up, we have to create a while loop. We're just gonna say while completed nodes.count is less than nodes.count. So this is just so this just checks if there are still nodes left, and if there are, then we have to keep going through this loop. So the first thing that we need to do in here is we need to check check nodes next to the current node. So in order to do this, we first need a list of integers called possible next nodes, and another list of integer called possible directions. And then we need an integer called current node index. This is the index of the current nodes inside of the nodes list rather than inside of the current path list. Nodes.index of current path dot count -1. Then we need an integer called a current node x, and we're going to set the to current node index divided by size.y, and an integer called a current node y, which is going to be equal to current node index percent mod, I think that's called, size.y. So this is just getting the position that we got inside of this list when we created the nodes. And that's going to be helpful for checking if there are nodes above and below and next to it. So now we have to actually check the nodes next to it. So in order to do that, we're going to use 4 if statements, one for each direction. So we're going to say if current node x is less than size.x -1. What this is going to do is check if it is on, or if it is below or before the right wall, so that it doesn't like choose one. What am I saying? This is just checking if it is on the right wall, and if it is on the wall, then there's none next to it, so it shouldn't go through this. But if it's not on the right wall, then we're going to say if not completed nodes dot contains nodes current node index plus size dot y, and not current path, dot contains nodes current node index plus size dot y. and then use your brackets. So what this if statement is saying is it's checking for the one next to it, and we have to do plus size.y because we're going by the y-axis, so you have to go all the way up through the y-axis to get to the next x-axis. And it's just checking if the node next to it or the node to the right of it is either in the completed nodes path or in the current path. If it's not in either of those, that means it's available, so it can continue, and that means it is another, like a possibility that it can move there. So then we're gonna say possible directions.add 1 and possible next nodes.add current node index plus size.y. So the possible directions, we're just adding 1, which just means this way it's completely arbitrary, but it just, you just need something to signify which direction it can move in. And then here, it's just the possible next nodes is just the actual nodes index itself. I said nodes index, didn't I? Okay, and then another if statement. This is going to be if current node x is greater than 0. So that's just checking if it is on the left wall. And if it's not on the left wall, then it can go through the loop or through the if statement. It's going to say basically the same thing again. If not completed nodes, that contains nodes current node index minus size.y, and not current path dot contains nodes current node index minus size.y. And then this time we're just gonna add possible directions dot add 2. Whoa, jeez. Instead of 1. And then possible next nodes dot add current node index minus size.y. I just realized I put this if statement inside of the other if statement. It's supposed to be outside of the if statement. I'm gonna actually comment these off. So this one is or this first if statement is node or check node to the right of the current node, and this one here is check node to the left of the current node, which is why we're subtracting here. This next one is going to be if it is above the current node, or we're going to check the one above it. We're going to say if current node y is less than size.y minus 1. So it's just checking if it's on the top or not. If it's not on the top, we can check node above the current node. So in here, we're going to say if not, well, basically the same thing again. So this time though, it is current node index plus 1. It's just going up. And not current path dot contains nodes current node index plus 1. And this one's just going to be possible directions dot add 3 and possible next nodes dot add current node index plus 1. Or, yeah, current node index. There we go. Okay, and now we just need one more, which is just below. So we're going to say current node y is greater than 0. And we're going to check node below the current node. We're going to say if not completed nodes dot contains. This is going to be nodes current node index, and we're going to say minus 1 instead of plus 1 this time. Let's do the same thing again, but for current path. And here we can just add 4 to the possible directions. And add current node index minus 1 to possible next nodes. And that's about it for checking the directions. We're not going to notice a difference right now if you press play, so there's not really a reason to, but we can move on now. Okay, so now we have to actually choose the next node. This is pretty simple. We're just going to say if possible directions dot count is greater than 0. So this is checking We're gonna actually comment this real quick, and we're gonna say choose next node. So this right here is just checking if there is a possible direction that it can move in. So if there is a free node or an available node next to the current node. And we're gonna say int chosen direction is equal to random.range from 0 to possible directions.count. And then we're gonna say maze node chosen node. So this just chooses which direction it's going to move in, and this is going to get the new node that it just chose. This is going to be the possible next nodes chosen direction. Why is this giving me an error? This right here is supposed to be nodes. There we go. Okay, so chosen node is equal to node the nodes with the index of possible next nodes index chosen direction, and then we can just simply set current path dot add chosen node, and then once again we're going to say chosen node dot set state node state dot current, because now it's adding it to that. All right, and we're going to put in a yield return null so that it doesn't crash, and then we can try it out. Okay, so it is really fast, but you can see that it did do a pretty good chunk of it. We're actually gonna do, instead of yield return null, we're gonna do yield return new wait for seconds 0.05f. So it's still quick, but now you can kind of see it in action. So we could press play again, and as you can see, it does indeed go until there's no more available nodes left. So just a couple of things left to do. First of all, we need to backtrack when there are no nodes left. So we have if there are possible directions and do all this stuff. But if there are no possible directions, then we need to backtrack so it can go back to when there were. So this is incredibly simple. All we need to do is just add an else statement and say completed nodes.add. We're gonna just add the current path or the current node, which is the current path index current path dot count -1. That's just the last in the list. And then we just need to do current path dot remove at current path dot count -1. So we're adding the current node to the completed nodes list and then removing it from the current path. We can also say current path dot count -1 dot set state node state dot completed. Now it'll turn blue. So now that should backtrack. And there you go. You can see that it backtracks, and it should go until the maze is completed. Super simple. So now we just have to get rid of the walls. So you go back into your maze node script. We have to create a new method. So this method is pretty simple. It's just going to be called, it's going to be a public void, and it's going to be called remove wall. And it's going to take in an integer called wall to remove. And here it's just going to say wall to remove .game object .set active false. You can also destroy it if you don't want it to be in the scene anymore, but if you don't know whether or not you want to reuse it later, you just set it to, or like unactivate it. Deactivate it, that's the right word. Okay, back into the maze generator script. Over here where we choose the next node, between when it actually chooses the node and when it adds it to the current path, we're going to make a new switch statement. This is going to take in chosen direction, or sorry, possible directions with the index chosen direction. And we're going to say case 1, chosen node dot remove wall 1. And then we're going to do current path dot count -1 dot remove wall 0. And break. I messed this one up a bit. There we go. Okay. So what does this mean? So if it chose case 1. Case 1 is to the right. So what we're going to do is, first of all, the chosen node removes the first wall. Now, I know I set these numbers a little weirdly because these don't really correspond very well. But the first wall is actually the left wall because it's index 1. And that's because the chosen node needs to get rid of its left wall, and the current node needs to get rid of its right wall. We're just removing the left wall from the chosen node, and this right here is the current node, and we're just removing the wall to the right of it. Next up, we need case 2, and this is going to be chosen node.remove wall, and it's just going to be the opposite. So it's going to be 0 for the chosen node, and for the current node, it's going to be 1. And you can put break again. Then we have case 3. Case 3 is upwards. So we have to remove the bottom wall from the chosen node, and the bottom wall is 3. And then from the current node, which is current path dot count -1, we have to remove the top wall, which is 2. And break. And then case 4, of course, is just the opposite, so you could just copy and paste it. And instead of 3 for the chosen wall, it's 2. And for the current node, it's 3. So now we should remove the walls. There you go. So as you can see, you now have a completed maze. So now the only thing left to do is to make it instant. You can create a new method for this if you want, unless you don't care about having this, but I'm going to. I have to actually copy all of it. Copy, paste. And we're gonna call this one generate maze instant. And we're gonna set this to void instead of IEnumerator. So we can get rid of all of the yield return nulls. All the yield returns, I mean. And you don't have to do this, but I'm going to. We're going to remove the set state variables so that it doesn't try to do any of that either. I think that's all of them. And up in the start method, we can comment out the start coroutine and put in generate maze instant. Take in a maze size, and now it should generate the maze instantaneously. There you go. And like if you get rid of the floors, for instance, it'll still work. There. So that's about it. Now you have randomly generated mazes. You can set this to any size you want, and it'll still work. So yeah, that's all I really have for today. So I hope this helped you. If you want to see anything else, let me know in the comments, and I'll see you all next time. Goodbye.